So in this lesson, I wish to talk about piecewise function, absolute value function, and their relation with limits. And of course, I try to make it short. Piecewise functions, we had some examples. And in the first week, there are some piecewise function recording that was done by me talking about how to graph those piecewise functions. And in the classroom, I talk about how to handle, there's a simpler way to handle piecewise functions, which is to, go by the interval and put different rules on the interval, okay? And such homework has shown up in homework number 3. Piecewise function, there are different pieces for different interval. And if we're looking for the points right at the place where the change of rule happens, then we need to apply the one-sided property, one-sided limit, okay? So like at point 1 here, the limit from left to 1 versus the limit from right to 1 is going to be a different rule. That's why we need to consider limit from left or limit from right. Okay, such examples have shown up many times, and we've done these lectures before. And because absolute value function also leads to piecewise functions, and we have done, we have discussed these quizzes. These questions on homework, and some of them is being quizzed. Okay. There are not a whole lot of questions for you to practice. And if you need more, please let me know. But for the limited number of exercise, I think the least thing you can do is that you do each one of them to really get better at this. This most recent quiz on homework number 4, it reflected that some of us still need work to work on these piecewise functions. For example, number 3, this is the one that showed up on the quiz, right? And the different rules, when we have different rules, and that's when we need to use one-sided limit. And in this case, we want to find the limit at this is the limit we're looking for. So come just copy the question, which is number 3, right? Number 3, you are already familiar with this. It's as x approaching 2. So we have x squared plus x minus 6 divided by absolute value of x minus 2. Okay. We need to understand that the absolute value of x minus 2 and x minus 2 is different, are different. Okay, these two functions are different. Okay, but how do we handle this? With x minus 2, you can do all kinds of operations, adding, subtracting, multiplying, dividing. But this absolute value of x minus 2, you cannot drop the absolute value sign without any reason. We need to know the sign of what's inside the absolute value before we can drop the sign. Okay, that's why we have 2 pieces of function, right? Let me give you, we all understand that the absolute value of x, when absolute value of x is considered, we cannot drop the absolute value sign unless we know the sign of x. And so if x is positive or 0, then the absolute value of x will be the same as x, right? There are many examples. If x itself is negative, then the absolute value of x is going to be the opposite of x. We had this discussion many times over, and here I'm not going to repeat it. If you need to study these lessons again, and which I highly recommend, some of you do need to study these lessons. You can find these lessons. I put it absolute value function here, property of absolute value in week 3. Okay, so please take your time to watch them. They're not terribly long, but they're really helpful for you to understand. We're not going to be done with absolute value function anytime soon, because from time to time, you still have to deal with absolute value functions, even when you're in calculus 2. Okay, you must learn how to handle this. So 2 pieces, and you can drop the absolute value sign if you know the sign of x. So this model will quickly turn into something like that. So this x can be anything. Okay, this x can be anything. So as long as we know the sign of that anything, we can draw the absolute value sign. So all this effort is to drop absolute value sign when we know the sign of the part which is being taken absolute value off. Okay, so this turn into this could help us to turn into a variety of things. And in the current situation we have multiple examples of absolute value functions. I would highly recommend you guys really practice with them. Really practice with them. Okay. And then you will be good at it. You'll be good at it. And for this question, you can see we have absolute value of x minus 2, and that's divided into x squared plus x minus 6. To reduce it, right? You can think of factoring the top, right? But you still cannot drop the absolute value sign because x is approaching 2. If x is approaching 2, x could be approaching 2 from smaller than 2. And x could also be approaching 2 from larger than 2. Okay, so I'm going to break down, and then I'm going to show you a final version of how to show work in the most, in a variety of ways, right? So we're dealing with this function. We're dealing with this function, right? And we know that this limit has to be considered from 2 sides. So in that case, we first handle x, the absolute value of x minus 2. Okay, which is right here. Okay. And when omega is x minus 2, you can see it's a simple substitution if you understand what you're doing. Right? X minus 2. And you would like to insert parentheses in this case, absolute value. It's a direct substitution. Okay, and what it says is that if x minus 2 is positive or 0, then the absolute value of x minus 2 is going to same as x minus 2. The absolute value of a negative number is going to be the opposite of x minus 2. That's all it's saying, which is the same narrative for this one. Okay, and then for the latter expression, you can solve the inequalities in the if part. Okay, so when you have x minus 2 greater than equal to 0, you can add 2 on both sides, and so this is going to be x less than 2. That's how you get x minus 2 and you made it into 2 pieces. Okay, so if you can draw the curve, but if you don't, you know that these 2 rules are different. And the other thing you'd like to consider is that when x approaching 2, the function is not defined at 2. So here, you might notice that the domain is x is not equals to 2. X not equals to 2. Okay, since x is not equals to 2, when we consider x minus 2 here, so you can just drop the equal case and just make it greater than 2, because that would be the most relevant to our current situation. Okay, so these are minor changes and you should consider, okay, as we progress. And next one is that you are taking this function. This function has a denominator, absolute value of x minus 2 has a denominator, it has a numerator. So the denominator has 2 branches. So this, as a result, this function will also have 2 branches. And these 2 branches, of course, is going to be it can be done this way. Okay, greater than 2, less than 2, and that piece will be divided into that numerator, which is going to be here, right? And the other one, which is going to be in the denominator, and you also have a numerator, which is a common for both parts. Okay, and you simplify. Okay, so let me grab this curly bracket, right? And you continue. We still have these 2 pieces, but now the top can be factored. Okay, the top can be factored into x minus 2 times x plus 3. Okay, so the same factoring scheme applies to the next one because they are identical. And these cases happens when x is not equals to 2. So we can do reduction. Okay, we can reduce x minus 2, x minus 2. So as a result, okay, the final one would be x minus 2 reduce x minus 2. So the top, so this one is just going to be x plus 3. And this x minus 2 take away this x minus 2. So the bottom will be left with negative of x plus 3. That's all you get. If you wish to simplify this way, okay? So this function now is into 2 pieces, right? We have now the convenience to apply, to observe limit from left and right. Okay, so when we observe limit from left, so when x is approaching 2 from smaller than 2, right? So let me grab, make it larger so you can see the sign. Okay, when x is approaching negative, when x is approaching 2 from smaller than 2, then we know x is smaller than 2, right? This is the branch when x is smaller than 2, and that limit would be the same as negative of x plus 3. Direct substitution, you have negative 2 plus 3, and that's going to be negative 5. And the other one would be when x is approaching 2 from larger than 2. These little signs makes a big difference. If you're missing them and you absolutely, you put yourself in the wrong position. Okay, so this time, when x is approaching 2 from larger than 2, that's when x is larger than 2, we just have x plus 3. And direct substitution, you're going to have 2 plus 3, that's equals to 5. The limit from left, okay, of the function is not the same as the limits from the right. Okay, and then you say, thus, that limit does not exist. We're quoting that theorem we're quoting that theorem. You know that theorem, what I'm quoting. And that's how you would do it. That's one way of showing your work. Okay, but if you want to separate the work, right, you look at limit from left, look at limit from right. And so you may like to write it, write it this way. In terms of presentation, you don't need to show these. Okay, you don't need to show that. Okay, so in terms of showing work, I think this is just step by step. You start with absolute value x minus 2, you get these two branches, and then you go about to do the given function with two branches. And then you just do the limit from left or from right. Other ways of presentation, of course, are possible, but just make sure your work is clear. And when I grade your work, and I have to admit that there's a lot of, I see a lot of confusion and improper expression. I cannot possibly address every one of such a mistake. That's going to make the lesson super long. But I do appreciate you guys, if you guys could come forward with your questions, so that way I can help you directly. I hope this lesson helps. Okay. And if you have any questions about these, please don't hesitate. It really is a matter of you get your hands dirty and really get to work on this. Okay. And yeah. And homework number 4, there's another piecewise functions, and these are not my invention. This is really from the textbook. I just took it. You would consider limit from left to right and how to do this. These are pretty familiar routines you've been doing. But think about this. When we talk about a limit, the rule on the left-hand side, the rule of the function is different from the rule on the right-hand side. And that's when you need to consider one-sided limit. Sometimes when we have one-sided limit, we still have limit, but sometimes the two-sided limit does not give us the same number. Well, of course, and tomorrow we're going to continue to discuss continuity, and you're going to see a variety of cases. We have covered on the new contents, continuity, right? We covered everything up to number 4. I'm sorry, not number 3. Okay, we didn't do number 3 yet. I will not be quizzing you on number 3. So just 1, 2, 3, A, B, C. Okay, number 2 and number 1. That's what we covered, and we have definitions about continuity. And so tomorrow we'll continue that discussion. And quiz-wise, I'll be quizzing you. The contents on, could be on quiz will be the first one, second one on homework number 5, and everything prior could be homework number 4, number 3, number 2, and number 1. Okay, so please get down your hands to the work. Okay, you really don't want to just watch, you want to do it. Okay, because when you start doing it, you notice there's so much details. There's so much details that you need to pay attention to. And if you don't, and those are the spots that you're gonna possibly lose points for it. Okay, so without further ado, and I will see you guys tomorrow. And thank you for watching.